Hey everyone. I think this is recording, so I should be able to post it on YouTube later. How's everyone doing? So let's see, we got about 2 minutes. Thanks, Jean. We got about 2 minutes before it looks like we are ready to start here. Oh no, we're right on time. Cool. All right, so we got 10 people. It's not bad, considering I did post this kind of late. So actually, I'd like to start us off the way we normally start off class, with a daily quiz. So go ahead and read over it. So we have this circuit, and this switch starts out open. So that means if the switch is open, it's like B doesn't exist yet. And so the question is, what will happen to the voltage through resistor A if we close the switch? And then, well, what's going to happen to the current through it? And then what about the total resistance of this circuit? So we have our original circuit, which is pretty much just A. And the question is, what's going to happen if we open it up to B? So go ahead, take about 5 minutes. Take a look at this. Feel free to call up someone, FaceTime them, chat, what have you, talk on here. So what do we think is going to happen? And then we're going to talk about physics fights, and they're posting AP lectures and what's going on with the official AP College Board right now. What's happening with the multiple choice waves test and how it looked. How problem set 10, I know we had some troubles with that, problem set 11. Then we're just going to go into SDLs and then do some practice problems on page 4 and 5. So really quick, try this. I'm going to pop away. I'll be looking at the chat, but I am going to mute me. So feel free to chat, but I want to see what you guys get out of this. Feel free to talk to other people. So yeah, this is not a particular page. I just, thank you, Jan. This is not a particular page. It's just in your, well, it's just on the board. So it's been 4 minutes. All right, so Jan thinks the voltage would stay the same. Do we have any other ideas? Feel free if someone wants to raise their hand and then talk. Danny, thoughts?
I think the voltage will stay the same. I'm just not sure about the currents.
Okay, so that's 3 people who've said it stays the same. Why would our voltage stay the same in this case?
Because it's parallel.
Yeah, they're in parallel. So things will change, but it's not going to be the voltage. So the moment this switch gets connected, we now just have a parallel circuit. So they're going to have the same voltage. The current is an interesting one, and I sort of wrote this on purpose. You could write a paragraph about what happens to the current here, because a couple things are going to happen. And so it depends on whether I'm asking about the current just for resistor A or just for resistor B, or if I'm asking about the current for the entire circuit. So let's think about the entire circuit for a second. If I open up a new path, what's going to happen to the entire circuit? What do you think? Yeah, somebody is making noise. I'm not entirely sure who it is. So if you are not planning to speak, I would recommend muting yourself. Somebody is shuffling. So thanks. Oh, nope, still going. But again, if you're shuffling, please mute yourself. All right. So we got some less current. What else? So anyone? Bueller? No. Okay. So think of it this way. If I open up a brand new road, so it was a 1-lane highway, and now I have a 2-lane highway, is traffic going to flow better or worse?
Better.
Yeah, it's going to go better. So that means my current, when I open or when I close this switch, my total current is going to increase. So because of this, my total current is going to increase. So my total current here will increase because I have now opened a brand new path. And so the reason for that is actually the resistance. If I open up 2 paths, your traffic gets better, which means your resistance went down. And we already said voltage is going to stay the same, which means your total current goes up. The interesting thing here is with A and B, if they're identical, nothing changes. If it's not, then it just depends which one has more resistance, which electrons are going to choose which path. All right, and so I sort of answered number C already. What's going to happen to our total resistance if we add something in parallel? Is my resistance going to go up or down?
No.
All right, down. And so current is kind of confusing, but the total resistance will absolutely go down when we add something in parallel. All right, so that's it for the daily quiz. Hope you did well. We're going to try to do these Zooms I think I'm going to do 3 times a week. So Monday, Wednesday, Friday at 1 p.m. Just so we kind of have a schedule. That's when class will start. All right. As far as a physics fight, I think I mentioned at the end of the last video that I am setting up a physics fight. Most likely it's looking like next week, where you guys are going to prepare arguments based on a question. You're going to have 2 minutes and you're going to record yourself. Or we're going to Skype. We're still working on how we're going to have you meet up with students from other schools. We're trying to organize a tournament, but right now it looks like it's just going to be a friendly between us and another school. So we're doing that just because it's really hard to do a whole lot else that's interactive right now. And I'll post what that looks like as well as an example, and then we'll do a practice problem just as a class so we can critique each other. So as far as the multiple choice, was anyone able to look at their results? I know some people asked me, they weren't sure how.
I did.
All right, Jan, how did you see, or were you able to see them?
Oh, it's Alex, but it's a Google Classroom. You just press, there's a little thing that says, it says like progress, and then it says like, no, it says assessment or something. And then you have to go to your specific one, like AP Physics 1. And then
when I did that, it only showed me like a bar chart. It didn't show me my score.
Wait, what do I press?
That's weird.
Yeah, because I have no idea what your guys' view looks like because I can't see the student view. I can only see my view, so I can see all your scores. So if you really, and I can even see like which questions you got wrong, which I'm hoping it does show you that. Alex, Jan, both of you said you guys could see it. Were you able to see which questions, or did it just show the score?
no, I was able to see what questions I got wrong and then what the right answer was too.
Okay, so Jan, I would check that out if you're interested. On that note, I just want to show, oh, I'm hearing someone's feedback of my voice. I'm gonna try to screen share it right here. And so that we can look at some of what I see. Have too many tabs open. Where is it? So these were our most common, our questions that we got wrong the most. This one is the one we got wrong the absolute most, which I find hilarious because all of you guys know this, which goes to show it's not always. So pretty much everyone answered that the amplitude of this was 2 meters. But remember, amplitude is the distance from the center. So the entire height of the wave is 2 meters. But if we're looking at the distance from the center, it would only be 1 meter.
Wait, who was the one person that got it right?
I don't know. Anyone here? Oh, Navi.
Navi.
Oh, I can look at that. That's cool. All right, the other one that we most commonly got wrong was this one, which I think mostly is just because we mixed up wavelength and period, or frequency and period, excuse me. So basically this one was asking, well, if I increase the period, what happens to the wavelength? And most of you guys were like, oh, increase? That means decrease the wavelength. But remember, an increase in the period means a decrease in the frequency, which would mean the other one would increase. So for the wave speed formula, V equals lambda F, if this is the period, if I increase the period, the frequency will decrease, which means we increase our wavelength. So you guys were thinking along the right lines. We flipped which way it goes. So overall, I was pretty happy with the results. Most people got 4s or 5s in general on them. I'm probably going to do these weekly just because this is a really quick way for me to be like, this is something we all don't get. This is all something we do get. And that gives me just a lot of good feedback.
Mr. Coy?
Yes.
I can't see like the results. Like it says that there's zero new results to view.
Interesting. Anyone else? Can we if we don't mind, I can actually just show all the scores if we don't care.
You can just post them. I mean, it's not that deep.
Yeah, post them.
So this is specifically 2. So this is the out of 16, and this is each individual one.
Okay, cool. Dang, Molly.
So again, on average, I felt like we did pretty good. Let's see if I can quickly go back to my other or first period.
Wait, what did I get?
You got 15.
All right.
Now he's cheating. 15 out of 16.
Okay, let's see if I can get back to first period. Oh, there we go. This is overall. So while we didn't have some people take it overall, most people are here in the green, which is either a 5 or a 4. And this is more in the 2-3 range. But nobody got a 1. So that's great.
Mr. Coy, how many did we have to get right to get like a 4 or a 5?
4 would be 50%, so 8 out of 16.
Heck yeah.
And then the
Can
5,
that be my score?
Wait, 8 out of 16 is what?
50%.
4. 50%, which is a 4.
Oh, I got a 7.
So
I got a 4. Heck yeah.
that's first period here, so I could show. And yeah, so for all these new results people, I'm going to start calling homes today. All right. Then whoever has people talking in the background, if you could mute yourself right now, that'd be great. And I'm grading problem set 10 right now. I know we've had some troubles uploading it. I'll try to make sure that's fixed for the next one, or I'll just, make sure it's just a typing one, so it's a lot less complicated. Apologies for the complexity on that. And so problem set 11 will be posted by the end of today, and again, it's going to be like maybe 2 questions this time, but again, just one Friday. Where we and then Ashley, I know Ashley has turned in the circuit. She had to send it directly to me. Has anyone else turned in the SDL number 1?
I did. Wait, can we turn that in today?
Yeah. It's due today.
Oh, okay. I thought it was due before.
I just wanted to check that we all kind of make sure you turn in that one before you move on to the second one. It's really important you do these in order. If you do them out of order, you won't really get anything out of it. You'll get through them fast, but you won't really learn a whole lot.
Oh, also the video notes today.
Yep, video notes today as well. I'm checking off. So after this video, I'm just grading the rest of the day. So feel free to contact me. I'll be on my computer, but I'm just going to be grading. As far as switching over to the new Google Classroom, second period is about 50% switched, and first period is about 70% switched. So again, I think I sent home emails as well as I'm going to start calling probably tomorrow because then I'll be done grading too. All right, with that in mind, if you could turn to page 4 in your packet, which should look like well, I'm going to draw the first one.
Hey, Navi.
What?
You still sick?
No, it was my wisdom tooth.
Oh. So, did you remove it or what?
No, it just like stopped hurting.
I just woke up. I slept at 5 in the morning.
Oh my god, I slept at 6.
Jeez.
Why?
We couldn't sleep. Our sleep schedules are like messed up.
I was playing video games.
Yeah. Okay, so guys, highly recommended. This is what I've been doing for myself because it's really weird. You kind of have a schedule, but you set your own schedule now because you essentially school from home. I would set yourself up like it's a normal school day. You pick so every Monday, Wednesday, Friday, you have a physics lecture. And then set aside times during the day that you're like, this is when I'm going to do this work. This is when I'm going to do this work. And my afternoons are for grading. My mornings are for prep. So in the mornings, I prepare everything for the day, like what we're going to do, what do we need to work on, organize with the other physics teachers. And then in the afternoons, I grade work. And in the middle of the day, you guys are going to be Monday, Wednesday, Friday, and regular is going to be Tuesday, Thursday lectures. So set up a schedule. Even if you can't turn off your cell phone in class. All right. So all I want you guys to do here, I only did two just because I was only going to really go over the first two. But what you want to do right now is circle the things in series and circle the things in parallel. And when you do this, especially in complex circuits, I'm going to do two different colors, blue and red. Maybe black and red. Or blue. Black and red. And you want to always start with the smallest piece you can. And what I mean by that is, if I can look at this whole circuit, there's a lot of things going on. I want to get to a place where there's only one thing happening. So starting with this one, this is, series, and then there's a parallel. This is in parallel, but these are in series. So the smallest thing I can do is that tiny little series right there. I just wrote an S. And so that's the tiniest piece we can do. Once we have that in series, where can I go out bigger? And so my next step is, well, in series, I'm going to go one step bigger and do all of, somehow did this. So one step bigger, and now this whole thing is in parallel. And then this whole thing, is this in series or parallel to this 5 ohm?
Series.
It's in series because it's this one and it hits this block. There's no or about it. I suck at color coding today. And so for each one of these, you just want to go through, and I'm going to draw on mine and show you. So right now, go through yours. I'm going to draw on mine in some colors and pen. Circle the things that are in series, circle the things that are in parallel, and start at the tiniest piece you can and work your way out.
Wait. Can you repeat that?
Yes. So to repeat, I want you to go on this page and circle the things that are in series and parallel. Start at the smallest piece you can, and then work your way back to the circuit. So here, this is in series to this whole jump. If you have the whole jump, focus on that piece first. I would start on this and then work your way back to the battery. So start as far away, the most complex piece, get it really tiny, and then work your way back to the battery.
Oh.
So try that, and I'll kind of show you guys the answers. It's just really hard to draw these neatly, so I'm just going to use my paper. I recommend using colors. It's obviously not mandatory, but it's just easy to see.
Nabi.
What?
Love you.
What?
Love you.
Thank you.
Is Giuseppe around? I don't think she is. No, actually, she's here.
Wait, so what? Oh, that. Wait, so what do we do?
Just gotta circle them.
All right, Laura, have we gotten somewhere? Because I have my answers, but I understand that I'm
Wait,
probably
I have
I
a
fast.
didn't do
question.
all of them because I feel like I'm wrong.
Look,
Okay, Eduardo, what was your question?
so for example, you see these three right here? One,
Oh,
two, three.
I can't actually see your screen right now. Give me a sec. Yeah.
So 1, 2, 3, and then there's one right here.
Uh-huh.
Aren't these in series? So I circle all of them.
Yes. So
You wouldn't circle them individually, right?
no, I wouldn't. I mean, so
Okay.
those three in that first one are, these three are in parallel. So that's your smallest thing.
Oh, okay.
And then this whole thing
In series.
is in series to the other.
So then, for the next one, this one is not in series with this one, right?
No,
This one is not in series with this one,
no. Those
but
are,
it's in series with this one
yes.
and this one with this one.
Yeah. All right. So, I mean, Eduardo's going through it, so I might as well. So, this is mine. It's backwards for me, but hopefully it's right side for you guys. So, we kind of did these two already. And for this one, notice you always want to start with your smallest circles. So these two little small circles here, those start in parallel. Those are in parallel. But each one of those branches off, and that whole thing is in series. But then this whole block here and this whole block here are in
Parallel.
And then this whole thing, everything is in series with these two right here that are on the main line. Right? For this next one, same thing. These two, they're in series. It hits this one and it hits this one. But then here we have all these choices, so they're in parallel. And then again, these are like mandatory. If it comes out the battery here, it's going to hit those two. They're in series. And the last and most complex one, we have a little tiny series here, branches out into a bigger parallel, branches out into a bigger series. We have our little parallel here, branches out into a bigger series. This whole section is parallel to this whole section. And then this big section is in series with this one single resistor.
Mr. Coy, the box on top of that last one,
This one,
the on top, that one, the middle one.
this one. No.
No,
This one.
yeah, right there where you have your finger. Those two, would you say they're in series, or do you just connect it with like the whole thing?
The C and D or the A and B?
Oh, wait.
EF?
Yeah.
Yeah, EF are in series because it hits E and then it hits F, and there's no or about that. It's an and, so it's series.
Wow.
Okay.
Okay, so the next step to this is doing equivalent resistance. So you'll notice these are exactly the same.
You're a magician.
Ooh. And so basically is you're going to use this as your guide to how to do equivalent resistance. And so equivalent resistance is, yes, we know each resistor number. That's great. But what's the resistance of the whole circuit? So it's like going onto Google Maps and you can look at the traffic in each little individual piece and you're like, oh, it's going to get really bad right at this junction, then it will get better. but you also just want to overall look at how bad is traffic really, and that's where it shows you it's your time is in orange, your time is in red, your time is in dark red, and you know it's bad and you should just probably stay home. And so that's basically what we want to do here. We know the individual resistors, but we want to know the total resistance or the equivalent resistance for the entire circuit. So I'm going to start with this one because it's the simplest. And we always want to start with the smallest piece. And that's why I said here, go find the smallest piece, circle it, and tell me what it is. So my smallest piece is in parallel. So REQ for parallel circuits works like this. You add them, but you add their fractions. Series is you just add them, so series are super easy.
What?
So for parallel, you add their fractions, and I'll show you what I mean. So this is my parallel. I have a 20 ohm resistor. I have a 10 ohm resistor. And I have,
Oh, I remember this.
and we're going to add them as fractions. So you do have to find your, lowest common multiple, I think, LCM. Anyway, so since this is a 20, a 10, a 10, my lowest common multiple could be 20. Yeah, I would go with 20, but you know, your short answer is you could just also multiply them together. It doesn't really matter. So this would get me 2 over 20 plus 2 over 20 plus 1 over 20, which hopefully we know 1 plus 2 plus 2 equals, everyone?
5.
5. Great.
That's what I said.
And so remember,
Did I mute myself?
this is, no, I can hear you, Eduardo.
Oh.
So this
I
is
feel like normal.
1 over the equivalent. So my last thing is I flipped them to get here. I have to flip them back. So we're going to flip this, and we're going to get 20 ohms over
So it's gonna
5.
be 4.
So it's going to be 4 ohms total.
Oh, that's not hard.
So, no, it's just for each one, you just have to take it slow. It's not like a difficult thing. It's just, you got to go through it. So for this one, I'm going to erase it because I have the luxury. And if we were in class, I would be making you do this on whiteboard, so you could erase it. But
Hi.
yeah. Oh, I know. I'm so hurt by it. So you can erase this whole thing. With a 4 ohm resistor. Your battery would not know the difference if you switched out all of those with one 4 ohm resistor. And so that's why we say equivalent resistance is we could swap out, once we do this, you could swap out whatever these were for whatever we end up with. And so now we have a much simpler. And so now our parallel is gone and we only have a series. And then for series, you just add them, which is nice. So my total resistance is going to be what?
6.
Yeah, it's just going to be 6, 2 plus 4. So this whole thing gets replaced by, so according to your battery, you could either have all of that going on, or you just could have put a 6 ohm resistor, and it would be the exact same thing. So that's what we mean by equivalent resistance. All right, Danny, if you're not going to talk, mute yourself. You're definitely shuffling over there. And so that's just kind of the basics of it. Questions? Okay, so
Are they gonna want us to redraw it like that?
No. So the redrawing I do for you guys. So when you are, and actually I do that for me too. When you are tackling a complex circuit, at least identify this and then go through it step by step. It's really easy to miss a step on a complex circuit. Real talk though, circuits aren't even going to be on the AP test. I don't know if you guys saw the update.
They said all the way to late March, right?
Yep. So the
I mean,
idea,
early.
yeah. So the idea is that
We can cheat on them. That's the idea.
I mean, here's the thing. If you guys cheated on the test,
Yes, a joke. It's just a joke.
I actually have no idea how it's going to look. It actually might mean you have to perform better to do better for that reason. So that means the idea that a 70% is probably a 5 and a 50% is probably a 4. I don't know if that's still going to be true.
Yeah, maybe they're more strict now.
Yeah,
They're
maybe
probably
it'll be
gonna
more
make it
strict.
harder.
And they said only 45-minute test, which doesn't make
Yeah.
sense.
And it's only FRQs.
So
Maybe we can do it with Jokoi and Nicole.
nope, absolutely.
Nobody has to know.
No. I'll know, so no. All right, so go ahead, try tackling this one, because I think this is the next easiest one. So yes, this isn't really on the AP test, so I'm not going to cover it as much, but for anyone going forward in physics, if you want to make sure you have seen circuits, you know a little bit about circuits, because I think it's important. Also, I think circuits is important because you live your entire lives on electronics, as we are proving right now.
Wait, so my lamp has those?
Yes.
Wow.
Wait. So circuits isn't even going to be on the test?
Uh-oh.
Like none of the things that we've been learning during this break? None of it?
Oh, you should say so. Oh, see you guys.
All right, I gotta go.
I mean,
Yeah, I gotta.
It would stop at waves.
I have some stuff to do right now.
yeah, so I think it looks like it's gonna do everything through what basically, I think they're not going to do waves, because the idea is that they pretty much are cutting out circuits and waves. So
The simplest stuff.
so simple harmonics is still in it. Rotation's definitely in there. So we're gonna start doing review starting this week. I'm gonna be posting materials, but I do want to make sure we at least get through basics. What?
Will all of like simple harmonics be on there, or will it be like basic simple harmonics?
Great question. I'm still trying to figure out the scope. I don't know if you guys noticed, but they are doing, AP is putting out videos on, their website. They're doing YouTube lives also, basically. One of them is a good friend of mine and the person whose class I'm trying to do the physics fight with, so you can watch his lectures, kind of get to know him. I'll post the link when it comes up, so he'll be
We want to see you with flipping physics.
well,
Do a collaboration with Mark Rober.
well, I'll start contacting people.
Because Mark Rober, like every Monday, Wednesday, and Friday, he said he's gonna do like physics videos and stuff with like lives, and like he usually has like dope like experiments.
Yeah.
I want to see you with flipping physics.
All right. Well, I'll talk to Mr. P. Maybe we can do a physics fight with his class. We'll see what happens. But we'll see.
Wait, you guys are friends?
I mean, we have talked. I mean, we're not close. We don't like hang out on the weekends. Not that we hang out with anyone.
No, you're not supposed to hang out now.
I know. But no, I've like talked. I support Mr. P's Patreon, because if it's saving me time, it's worth my money. So, and then Mr. Jacobs, he writes 5 Steps to a 5. We've been in contact for a couple years now, because he's been teaching it a lot longer than me. So thanks, Jocelyn. He's been teaching a lot longer than me, so I shamelessly steal his stuff whenever he lets me.
Wait, Mr. Coy,
Yes.
how would you think they would do the AP English test if it's only 45 minutes?
They're probably gonna do just
Multiple
One
questions.
essay?
Just the writing?
probably
Because
just
there's supposed to be 3 essays, and then there's supposed to be multiple choice. Will they just do like 1 essay then?
Yeah, I think they might just do like one essay, which honestly to me is a lot scarier than the full thing. The full thing you'll get tired, but you're like, I didn't do well on that one, but I have another chance. One question is like, you got to do good on this one question.
Let's hope it's all rhetorical analysis.
Amazing.
What if you don't do any question at all?
So probably if they're doing a 45-minute, I think they're going to do one 25-minute question, and then like 2 of the 15-minute questions, or 13-minute questions, is what I would expect. Again, we don't really know. We'll get more information as we get closer. But then they're also going to do early testing if you want to do early testing. So I'll keep you guys updated on anything like major deadlines and so forth. But I don't want to spend our time with this because we only get so much time on.
It's okay.
Because it's free. Maybe we'll get people to pay for it eventually, but not right now. All right. So have you guys tried this one yet?
Yes.
Okay.
Yes.
All right. What do we get?
Maybe.
Okay, let's go through it. So we have our
I think
first
it's a try hard.
series. So 8 and 2 give us
10.
10. And then we have a 10 and a 10, which gives us
1.
5.
Oh, 5. I was wrong.
So here's the cool thing with parallel. Here's a always quick check. If you're there in series, your resistance is going to increase, right? 2 plus 8 got you 10, more than just in any single one. In parallel, your resistance will always be less than any single resistor. So I know my resistance has to be less than 10. And the reason for that is because of this idea of the fraction. So it'd be 1 over 10 plus 1 over 10, which gets us 2 over 10. And then if we flip it, we get 10 over 2 or 5.
Mm-hmm.
If they're identical, basically I memorized, if they're identical, they get cut in half. You don't have to memorize that. You can. So they're going to have a 5 ohm and a 5 ohm, and those are in series, so we're going to get a total of 5 plus 5.
10.
10, yay. Yeah. What would be my amperage here? Or excuse me, what would be my current? If my voltage is 40 and my total resistance is 10, what's my total current?
Four?
4. Or 4 amps. Which is a crazy amount of current. Please never try to get 4 amps on your little breadboard. That's way too much. So whenever you're trying to solve these, and probably next Wednesday we'll actually do VIRP charts, VIRP charts. But this is where we're going, is now that we can do all the pieces, we understand how they fit together, now we can actually solve for individual parts of it. So for your practice, I highly recommend going through. If you want, I can post answers to each one of these with work shown by me. But that's kind of all I wanted to get through today. Do we have any questions going forward, how to do this? This is about as complex as I would ever expect them to throw a problem at you. As far as college goes, this gets harder and they do more. But it's just, if you know the basics, it's just how do you do the basics better?
Mr. Coy, what is that you wrote like at the bottom B? Like I know that's an equation, right? The V
Yes.
equals.
So this is Ohm's law.
Okay.
And so Ohm's law states that as your
I forgot about it.
So the idea of Ohm's law that is if you increase your current and increase your voltage, you should have a constant resistance. The
Okay.
idea of Ohm's law is that the resistor should be constant. So we'll say sometimes a light bulb is either ohmic or non-ohmic. So if it's ohmic, it follows this law. Most light bulbs are actually non-ohmic, which is why we don't actually use light bulbs in our testing. We use resistors. The resistors are pretty ohmic unless you get them extremely hot, which is why we lower the current so that they don't actually get hot. Because as things get hot, or they tend to be non-ohmic and they start to do this. And so their resistance gets much higher because our slope gets steeper. So their resistance gets higher as they get hotter. So it's hotter, it's harder for the electrons to get through because there's so many things moving and getting in their way.
Okay.
And this is what light bulbs do, and that's why incandescent light bulbs get hot and they light up and they release that energy as light and heat. So LEDs are a little more ohmic, I'm pretty sure, and the idea is that we aren't losing all this energy to get them getting hot. But great question. Any additional questions? No, we're good?
When is SDL2 due?
What do we think? So SDL1, I was gonna have one due a day. Like 1 is due today, 2 is due tomorrow, 3 is due Wednesday, and so forth.
Okay. And when we turn stuff in, we email it to you, or do we put it on the classroom?
Great question. Please turn it into the classroom. If I have already graded it, then you should probably just email it to me because I'm not going to go back and look at the old classroom posts.
It doesn't tells you when somebody submits it.
It
Wait,
does.
oh, go ahead.
But so yeah, so actually on that note, just go ahead if it's late, like before we started to being online only, please email it to me. So no, Jan, do not email your STLs. So please turn them into Google Classroom. Please turn them into Google Classroom. Anything that was from before we were online only, you can just email them to me.
Oh, okay, okay.
Please put in the word late, because what I'm going to do is when I go back to grade, I just search late in my email history, and then it will just pop all the ones I need to grade up. If you don't put late, I just may never find it, because I'm getting so many emails because everything is online now. All right, all good questions. Any additional questions before we phase out here?
So if we got prep books, do we and we're trying to study for the test? Would we just skip the circuits and the waves part and then not do the multiple choice, or should we
So if you are studying just to pass the AP test, then yes, that's absolutely what I would do. If you're just studying because you want to make sure you're ready for next year or next whatever you're going to do, study all of it. But if you're specifically studying to pass the AP test, I would, if you don't have the time, drop the circuits, drop waves.
And then is it going to be like this next year too, or is it just for this year?
We don't know. I have no idea what's going to happen. I have no idea what's going to happen after 4 weeks. And even if we are back in school after spring break, I won't be. So
Why?
because my dad's surgery is that Wednesday after spring break, and he's going to need 24-hour care, so we're all doing rounds. So I will be absent quite a bit at that time, which I told Whitmire about a couple months ago as soon as I found out. So if we're still just doing online class, then that's fine. I'll just do online. My brother has a whiteboard in his room, so I'll just set up in there.
Technically speaking, we're getting worse with the coronavirus.
It'll get worse before it gets better.
I know. We're in second place already.
Okay. At least we're not first.
We're not far from first, I think.
Well, we are the most populous state and one of the most dense states, so that's not too hard.
I mean, eventually Brazil is gonna start getting infected too, and all the big countries.
Yeah, it's probably gonna make its rounds. So it's mostly trying to figure out, well, how do we best mitigate that? And so Yeah.
When are we getting the answers for the study little flashcards?
Right. Thank you. I actually forgot to do that today. Your answer today. I'll do them today.
Okay.
Obviously there is going to be less focus on the circuits ones. I'm still really not sure how I'm going to test you on this. But you should think of them as you're studying for the AP test. It's online now, so I mean, if you kept your flashcards with you, I don't know if anyone would know. But they are extremely Kahoot. I'm gonna be honest, I hate Kahoot. It's such a pain to set up.
What about quizzes or something?
I might, but it's mostly that I can't really do open response, and they're extremely difficult to grade. So I have to make multiple choice questions, and writing multiple choice questions takes way longer than writing free response questions. I would say probably 4 to 5 times longer.
Wait, so when will we be able to see the score for the test we took?
The waves?
Yeah, the one on College Board.
It should be up.
I checked like 2 minutes ago. It wasn't. I couldn't.
Navi, you got a 15.
You got 15 out of 16, Navi.
Well, I want to see what I got wrong.
It doesn't matter.
No, so I think you can look. I think some people can. Some people have been able to look, so I think it's in there, but I think you got to play with the settings. I don't think its user interface is particularly well formatted. I have trouble getting around on that website. So that's fine. I would fiddle around with it. I'll probably be giving out another quiz. I don't know. How do we feel about just Friday is quiz day?
Sure.
Okay.
A quiz? Okay, like the waves quiz?
Yeah, so I'll probably do a tiny circuits one, and then I'll start doing review quizzes. And again, I'm not like grading you harshly on these. These are just so we know what our progress is, because I can't judge your progress, and I don't see you every day. It's a lot harder. So again, I'm mostly grading you guys on that you're doing things and that you're interacting, and then I'm calling home for people who are not. So that's going to be starting tomorrow, because I emailed home today. We'll see if that fixes anything, and I'll start calling homes tomorrow. All right, great.
A question.
Yes.
What about like all the people who were in third place? 42,000. No. What about all the people that never comes to like video calls or like? Does that affect them?
The coming to video calls or turning in work?
Not like coming here, socialize with us.
No, I'm not taking attendance. I, however, am grading things you turn in, so I'm assuming that you're just great at this already, which, awesome. You'll probably need at least some help with this, but how you get that help is entirely up to you guys. If you want to do it through me, your friends, the internet, that's fine. If you're just doing it through the internet, you might I find it less helpful, because it's not catered for you guys.
Tengo hambre, Mr. Coy. Tengo hambre.
Mr. Coy?
Yes, Catalina?
Do you mind doing another example? Like the first one?
This?
Yeah, like writing it out, because I kind of got confused.
All right, sure, which one? I could just make up one.
Yeah, it doesn't really matter.
Navi. Navi.
Can you not?
What?
What are you doing?
I'm trying to fix my Wi-Fi.
What's up with your Wi-Fi?
I guess one of the cables isn't working correctly,
Stop stealing the Wi-Fi from your neighbor.
but I'm not.
Anyway. Eduardo, you're on timeout. So, all right. So, Catalina, we would want to start with this section right here. So the furthest from our battery, almost literally, and the most condensed section. I don't want to start here because there's this and then all this other stuff. So I'm going to start right here. These are in series, so since they're in series, I can just add them. So we're like, great. This is 4 plus 6, which gives us a total of
10.
10.
She forgot to have
Now,
my
our
phone.
next one is a bit bigger.
Mm-hmm.
So now this is all going to be in parallel. So I'm going to add them, but they're in parallel, so I'm adding them as fractions.
Okay.
So we have, again, we can just turn these all into 20s.
Wait, why do you put a 2 now?
Just because 1 over 10 is equal to 2 over 20.
Okay.
So yeah, it was just me converting my fractions into, so they all have the same denominator.
Bottoms. Okay. Cool.
Yep. And so when I add them, I get 5 over 20. And so I flip them to make this happen. I have to flip them back as a final step here. And then I can simplify. So it means this whole section now
It's 4.
is just 4. And so now I can kind of do the last thing, which now I can see, well, it's going to hit this, and it's going to hit this, and it's going to hit this. So now we're just all in series.
Mm-hmm.
So it's another straight addition. So 4 plus 4 plus 3.
11.
This gets you 11.
Oh, so the ones in parallel, you would do the fraction, and then the ones in series, you just add them.
Yes, absolutely.
Oh,
So that's why
now
it's
I
so
get it.
important that we can carefully partition out, oh, these are only in series, these are only in parallel. You can't add something that's in series and parallel at the same time.
Okay, now I get it.
Let's section it out. Where we're going with this next is we're going to be doing something that's called VIRP charts or VIRP charts, where you just have the voltage, the current, the resistance, and the power. Through each resistor. So that's where you figure out what's the voltage in each resistor, the current in each resistor, the resistance of each resistor, and how much power each resistor uses.
Wait, so the 11 for this, like this thing, what is that ohms? Just 11 ohms?
Yep, and that's the total resistance for the entire circuit.
Okay.
So let's say this was a 22 volt battery. My entire voltage would be 22 volts, which means my current would be 2 amps. V equals I times R. So 2 times 11 gets us 22 volts. The power is equal to current times voltage. So the more electricity you have going through it versus how much energy each electron has will get you more power. Because remember, current is charges per time. Voltage is energy per charge. And this gets us the amount of energy over time, which is power, right? Work over time is power. So in this case, it would be 44 watts. And so for each little resistor, you can go back and solve this. So obviously there's more than 5 or 4 resistors here. I've only seen them do a 4 resistor circuit on an actual test. Again, not that it matters for us this particular year, but that's about the extent of it. And so that's where we're going next, is now how do we solve this whole thing? And we use that by doing our total resistance, our total current, our total voltage. We use our rules about parallel always gets the same Parallel
Voltage.
resistors always get the same voltage. Resistors in series always get the same
Current.
current. And so that's how you use that to help yourself fill out the rest of this chart, which we will go over on Wednesday. Yes. And
What is the 2A?
what?
The 2A, like next to 22 voltage.
It's the current 2 amps.
Where do you get that?
So that just came from the equation V equals IR. So I just made up a voltage.
Oh, okay.
And if my total resistance is 11 and my total voltage is 22, my total current is going to be 2 amps.
Ain't that similar to what you do on the SDLs, like for that little prediction chart? Okay.
That's why it's set up that way. It's so that it looks like our formal solving charts.
And you just make up numbers for that? Like there's no numbers you actually have to. Okay.
Yeah, make them up. And so basically the goal is by the end of this, you'll just sort of have an intuitive understanding of like, oh, this is probably going to be about this. Because you'll predict, you'll test it and be like, okay, well, I was kind of right. And so I really do want to look at your guys' first predictions before we move on to the second. I am going to comment on things and return them to you. And so that's what I'm going to be doing right now is I'm going to try to do as much grading as I can before it hits 5 p.m., which I've set as my, I'm done with work for the day. Do you still have a question, Eduardo?
I'm fine. Thank you.
Okay, I'm going to lower your hand then. All right, any questions moving forward, or we feel pretty good for the day?
I think we're good.
So probably
Wait, so when will the next meeting be?
Wednesday, 1 p.m.
Wednesday.
Why not tomorrow?
Because I'm going to do regular tomorrow.
And then the SDOs.
Are they actually showing up?
I have about had about a third of the class show up.
Oh.
So
Wait, so the SDOs will be due daily too, or no?
yes, so I'm going to have SDLs do daily, just so, because if this was actual class, that's what I would be doing. There's about 9 SDLs. 7 is mandatory, 2 are extra credit. And I would be having you do 1 to 2 per day.
So today we're turning the SDLs in the notes.
Yes, so turn in at least SDL 1 in notes and then SDL 2, and I'll put those up today.
Wait, is SDL 2 due today or tomorrow?
Tomorrow.
Okay.
So think of it, do 1 SDL today, and then we're going to start doing review work next week.
So SDLs are like problem sets now.
Kind of. Well, SDLs are what we would be doing in class, and we'd be doing them daily. But we don't officially have class. So
And we'll be doing the flashcards next week as well then?
doing the what?
The flashcards?
Yeah, I'm still figuring out how to test you guys on them. I am going to test you on them. I'll post answers today, but keep studying them. They should all hopefully be things you kind of know, or at least sound vaguely familiar, because we've pretty much covered all of the basics by now, except electricity, but we've pretty much done it all. All right, we good?
You see the dog?
The dog just got medicine put on them, so I'm not gonna hold them. You can go watch her in her natural environment of being extremely lazy. This is pretty much what she does all day.
I thought you said it was a racing dog.
Yeah. 45-mile-per-hour couch potatoes.
Oh,
Hi, June.
Why are they on medicine?
Oh, it's just flea and tick medicine.
Uh,
Hi, honey. You scared of the laptop? So she's still nervous. Yeah, you are. It's okay.
I hate the laptop too.
Jocelyn said, let's say hi to your husband.
yeah.
How many pets do you have?
I have 2 dogs, 1 rat.
Oh, okay.
Bro, that rat is living better than me.
The rat does live pretty well. Hi, honey.
I got all them toys and everything, bro. Yeah. Even I didn't even have them toys.
It's because she's rich.
Come on, honey.
Yeah.
Come on out.
Make her do the roll.
Her spins?
Yeah.
It's her sleepy time.
Oh, never mind.
She has a schedule. Jacob, what is that?
What's what?
Let the rat just be herself. Is that she or he?
Yeah, that is herself. She gets to do what she wants.
Oh.
She's old, so she gets to do whatever she wants.
When you say oh, it's like
She's 2.5.
Wait, so we can't say hi to your famous Russian husband?
He's working.
Wait, he's Russian?
Yes.
Oh my god, how do you guys don't know this yet?
But does he speak to you in English?
Yes.
Oh, okay.
He came here when he was 4, so he speaks.
Oh.
His parents have an accent, but
But do you guys like have conversations with German?
no, I don't speak Russian.
I mean, Russian.
I speak. My Spanish is way better than my Russian. I'm working on it though.
yeah, Miss Yoko is 50% Mexican.
Okay. I'm gonna go. I'll try to post this on YouTube later, although it's gonna be kind of awkward. I feel like to watch a meeting, but you know, if you missed it, you missed it. All right. I'll talk to you guys later. Maybe I will try to get Shy Husband online at some point when he is not working. Bye, guys.
Bye, Mr. Coy.
Bye, Navi.
Bye.